Okay, so we're going to be multiplying with radicals, multiplying single terms by binomials and binomials by binomials. So we treat those like regular binomials that we would multiply where we distribute or FOIL. It's just we're going to have to deal with radicals, making sure that we multiply things that are in the right positions. Remember, numbers that are not under the radical get multiplied with other numbers that are not under the radical. And numbers under the radical get multiplied with other numbers under the radical, and then we need to make sure we simplify. So we're going to start with number 1, 2 square roots of x times the binomial 8 minus the square root of 1/2. Everybody ready? Okay. All right, so we're going to start by taking and multiplying 2 square roots of 6 times 8. And again, remember, the parts that are in the same position get multiplied together. So 2 square roots of 6 times 8, what two numbers actually get multiplied together? The 2 and the 8, yep, so that becomes 16 square roots of 6. Bring down that minus sign. And then we're going to multiply 2 square roots of 6 times the square root of 1/2. Again, the numbers that are under the radical get multiplied together. That 2 is going to stay in the front. It doesn't have anything to multiply by besides 1. And don't let the fraction scare you. If I multiply 6 times 1/2, what is 1/2 of 6? 3. So the square root of 6 times the square root of 1/2 turns into the square root of 3. Once you do the multiplying, you want to then check to see, first of all, can you simplify either radical any further than it already is? Can we simplify the square root of 6? No. Can we simplify the square root of 3? No. And then you want to try to add or subtract. And remember, in order to do that, they have to be the same radicals. Are these the same radicals? No. So I can't really do anything other than the distributing. So we would leave our answer just like that. If you will go ahead and start number 2, go ahead and distribute that square root of 6 to both terms inside of parentheses. Once you distribute, then I want you to try to see if you can simplify each radical. So again, distribute that square root of 6 to both terms inside your parentheses. Once you do that, then you want to see, can you simplify each radical? When I multiply the square root of 6 times the square root of 3, I get the square root of 18, yep. And then I multiply the square root of 6 times 2 square roots of 15. That's going to give me 2 square roots of 90. But we have to try to simplify. So start with 18. Is 18 a perfect square? No. Is there a perfect square that divides into 18? Yes, the 9. So we're going to split that apart. We're going to do the square root of 9 times the square root of 2, which turns into 3 square roots of 2. Then we want to do the same thing with that second term. I want to try to simplify 90. It is not a perfect square. Does it have a perfect square that divides into it? 9 times 10. So we're going to leave the 2 for now. We're going to split that up into the square root of 9 times the square root of 10. Leave the 2. The square root of 9 turns to 3. And then we can actually multiply those. I'm going to bring down that 3 square roots of 2. 2 times 3 is 6. So I get 3 square roots of 2 plus 6 square roots of 10. Can I actually add those together now? No. Okay, they're still not the same. So we cannot bring them together. We would leave our answer just like that. You do have to simplify it, though, from the square root of 18 plus 2 square roots of 19. You don't lose some points. Everybody okay with those? All right, take a minute and write down number 3. We'll work through this one together, then I'll let you try 4. I have a binomial times a binomial, so I'm going to do the FOILing process. Each term in the first parenthesis gets multiplied by each term in the second parenthesis. So let's start with 8. When I multiply 8 times 6, do I actually multiply those? Yes, they're both outside of the radical, so we will multiply. And that gives us 48. Then I'm going to multiply 8 times a positive square root of 2, which is going to give me a positive 8 square roots of 2. 8's not under the radical, the 2 is, so we cannot multiply for 16. I'm going to just leave it as 8 times the square root of 2. Then we're going to do a negative square root of 2 times 6, which gives me a negative 6 square roots of 2. And then I'm going to multiply a negative square root of 2 times a positive square root of 2, which is going to give me a negative square root of 4. Now, I do have a couple of like terms, don't know that I can simplify. Put together. You see anything else that needs to simplify here? That 4 is a perfect square, right? So we need to go ahead and simplify that as well. What is that going to turn into? 2. Okay, so then we can work on our like terms. We have 2 terms that do not have radicals, so I'm going to combine those. 48 minus 2, what does that give me? 46. And then I have a positive 8 square roots of 2 and a negative 6 square roots of 2, which is going to give me a positive 2 square roots of 2. And then just double check to see if our radical can simplify any further. Does the square root of 2 simplify? No. So I'll leave it just like that. I want you to try 4. All right, again, we're going to just do our FOILing process. I'm going to start 2 square roots of 3 times 4 square roots of 3. Outside times outside, inside times inside is going to give me 8 square roots of 9. Okay. Then 2 square roots of 3 times 3 square roots of 2 is going to give me a positive 6 square roots of 6, right? Okay. And then I'm going to do a negative 2 times 4 square roots of 3, which is going to give me a negative 4 square roots of 6. And a negative square root of 2 times a positive 3 square roots of 2 is going to give me a negative 3 square roots of 4. Now, before I start trying to simplify, most of the time when you have some radicals that you're multiplying, you get with some perfect squares that can simplify. Do you see perfect squares we can simplify? The 4 and the 9. So this is technically going to be 8 times the square root of 9, which is 3. I'm going to leave everything else the same for right now. And then this is going to be 3 times the square root of 4, which is actually 2. So 8 times 3 is 24. And I'm writing everything because I'm not combining terms yet. You can do a couple of these steps together. Now we're ready to combine our like terms. Numbers without the radicals. 24 minus 6 is 18. And then the numbers with the radical. Positive 6 square roots of 6 and a negative 4 square roots of 6 is going to give me a positive 2 square roots of 6. And then can I simplify that square root of 6 at all? No. And so just make sure you distribute, multiplying things that are in the same place. Simplify any perfect squares, combine your like terms, and then just double check to see if any of your radicals can simplify any further. Everybody okay with that one? This one? This 3 right here?
No,
this one?
Times 3.
Oh, from the square root of 9, that simplifies to be 3. All right, I want you to try both of these, but I want to also just talk about something before you multiply. We'll see if you recognize anything. For number 5, I have 2 plus the square root of 3 times 2 minus the square root of 3. What do you notice? They're the same except for one's a plus and one's a minus, right? Is that the truth? Try that one more time. Is that true for number 6 as well? Are they exactly the same except for one's a plus and one's a minus? Okay. Those are what we call conjugates, when you have 2 binomials that are the same except for your signs. And something special happens when we multiply these. Hold on, sorry. Okay, they're called conjugates. And I want you to go ahead and do the multiplying process and take a look at your answer. Let's see what happens when we multiply a pair of conjugates involving radicals. The process is the same, it's just our answer is going to look a little different than it has before. So if we kind of pay attention to how our answers looked for 1 through 4 versus how they're looking for 5 and 6. In questions 1, 2, 3, and 4, didn't all of my answers have square roots in them? What are you noticing about your answers when you multiply these conjugates? What happens to your square roots? They cancel out. They disappear, right? So when you multiply a pair of conjugates involving radicals, let's go through the process. 2 times 2 is 4. That's going to give me a negative 2 square roots of 3. That's a positive 2 square roots of 3. And that's going to be a negative square root of 9. Now 4 is a perfect square, but it is not under the radical, so it does not simplify. But that square root of 9 does turn to just 3. And then I'm going to combine my like terms. What's 4 minus 3? 1. And then a negative 2 square roots of 3 and a positive 2 square roots of 3 just cancel out. Negative 2 plus 2 is 0. Remember we talked about that the other day. When it goes to 0, we don't stick a radical on it. So my answer here is just 1. Anytime you multiply a pair of conjugates involving radicals, meaning 2 binomials that are the same, except for one's a plus and one's a minus, your radicals cancel out and you end up with a whole number answer. It can be a positive number or a negative number, but it is just a whole number without radicals. So if we do the same thing for 6, 2 square roots of 3 times 2 square roots of 3 is 4 square roots of 9. 2 square roots of 3 times the square root of 2 is a positive 2 square roots of 6. Negative square root of 2 times 2 square roots of 3 is a negative 2 square roots of 6. And negative square root of 2 and a positive square root of 2 gives me a negative square root of 4. I'm going to simplify my perfect squares first. 4 times 3 is 12. Goodness gracious. And then I can combine my like terms. The two parts that don't have radicals is a 12 and a minus 2, which is going to give me 10. And then a positive 2 square roots of 6 and a negative 2 square roots of 6 cancel each other out. So we're left with just 10. Okay? We're going to need to remember that tomorrow, just FYI, about multiplying conjugates and our radicals disappearing. I got 2 more for us. Is everybody ready? Now, we've multiplied binomials that are squared before. I just want to remind you that if I do a binomial and I square it, what is the very first thing I need to do? Because squaring means I multiply something by itself. So I'm going to need to write that binomial twice. Okay, do not just try to square each term. You want to write it twice. And then you can do your FOILing process. Whoops. Same thing for number 8. Write it twice. Nothing changes with it. It stays exactly the same in both of your parentheses. Okay, these are not conjugates because they're exactly the same. They're not opposite signs. So we should not get just whole number answers. We should have radicals in our answers. All right, I'm going to start multiplying. 2 times 2 is 4. 2 times the square root of 3 is a positive 2 square roots of 3. Square root of 3 times 2 is another positive 2 square roots of 3. And the square root of 3 times the square root of 3 is the square root of 9. But that square root of 9 turns into just what? 3. So if I combine my like terms, what's 4 plus 3? 7. And then a positive 2 square roots of 3 and a positive 2 square roots of 3. Those do not cancel out. They add together to give me a 4 square roots of 3. So we should have gotten 7 plus 4 square roots of 3 there. Is everybody okay with that? All right, and then number 8, same concept. We wrote it twice. We're going to multiply. Square root of 7 times the square root of 7 is the square root of 49. Square root of 7 times negative 2 is a negative 2 square roots of 7. Another negative 2 times the square root of 7 is another negative 2 square roots of 7. Goodness. Negative 2 times negative 2 is a positive 4. My perfect square is 49. It changes to what? 7. So what is 7 plus 4? 11. And then a negative 2 square roots of 7 and a negative 2 square roots of 7 gives me a negative 4 square roots of 7. Perfect. Anybody have any questions?